All right, welcome back. Today's lesson is about kind of getting into our next unit about starting to write names and formulas of chemical compounds. This is going to be broken up into a couple of different subsegments. So this one right here, we're just focusing on some basics. This is going to be something called binary ionic compounds. We'll talk about what that means in a second. But there will be some future lessons that focus on a little bit more difficult or different varieties of compounds that are coming up. So this one's just focused simply on binary ionic compounds, which are metal-nonmetal compounds. So where do we start? This kind of model that I'm kind of putting here is an important thing to always start when you're trying to write names and formulas. A couple basic questions. Number one, how many elements are present? And number two, what kinds of elements are present? Because once you start to know those things, that's going to give you sort of a path for doing some naming procedures in terms of figuring out what's what. So you can take a look at the examples that are up here on the board, or on the screen, I guess. And the first question I always want to ask is, there are two elements present, or are there more than two elements present? Not atoms, but elements. And then the second one is, what kinds of elements are present? Do we have active metals in a nonmetal? Do we have transition metals in a nonmetal? Do we have just nonmetals, or do we have some scary looking thing that's on there? So with these, I'll give you kind of a second here to kind of look these formulas over. There's a whole bunch of them in here to kind of start thinking about, all right, is this a metal or a nonmetal, active metal, nonmetal? Remember, active metals, I'm defining those as alkali metals, alkaline earth metals, and aluminum basically kind of fall into that category. So let's take a look at what we've got here. This particular lesson is only going to focus on binary ionic compounds. So let's take that phrase apart so you can kind of see what it means. First of all, compounds are anything that's made of two or more different elements. These are only going to be binary compounds, and binary here means there's just two elements that are present. We'll get to the more than two elements in a lesson or two from now. And then the third one is ionic, and again, ionic refers to the type of bond that's in there, where we've got a cation and an anion that are bound together because of electrostatic attraction. So there's plus minus, and they're sticking together like those magnets. That means that there has to be a metal and a nonmetal that are present. We'll get to nonmetal in a different video. So binary ionic compounds refers to two elements that's a metal and a nonmetal only that's present. So take a look at this little list. Here's this list from the other screen. Can you tell me which of these things, take a second to identify which of these would be classified as binary ionic? So you can hit pause if you want to, but take a look through all, whatever, 8 of them that's on here, and decide, is that binary ionic? Is that something else? Okay, hit pause, take a look at it. All right, here we go. So here's the ones that don't count. MgNO3, more than 2. NH4Cl, more than 2, not binary. And then CO2 is going to go away because that's 2 nonmetals, so that wouldn't count. The ones that are remaining on here are all binary ionic. And then the next question we want to add to our list is, which of these would be considered to be active metals versus transition metals and a compound that's in there. So again, take a look kind of closely, see what else you can kind of eliminate or sort into 2 different piles here. Okay. When we look at these, I got them kind of color-coded on here. The active metals would be the ones that are in green. And again, active metals are the ones that are in the first 2 columns of the periodic table plus aluminum. I would call transition metals anything that's in the center of the periodic table, or the Harry Potter metals, as I've called those before. And we're going to call those different names. Just for a shortcut, we're going to call active metal compounds type 1s, and we're going to call transition metal compounds type 2s. It's just a little bit faster, but yes, you will need to know which ones are type 1s and which ones are type 2s. So if you can get to that point, okay, these are binary, they're ionic, and now they're type 1 versus type 2. Because the rules are different for how you name them. That's why we have to figure that stuff out. All right, so let's give a couple of examples here. Type 1 binary ionic compounds. This is active metal and nonmetal. These are the ones that we actually started to do in the last unit that we've already covered. We know these charges from the periodic table. We use the process of crossing down to write use the charges to create subscripts. And then the basic remembering of not putting charges in a final formula. Charges is kind of part of a rough draft, I guess, if you want to call it that way. So here's the example that you should try, just as a review. Can you write the formula for the binary ionic compound formed between aluminum and oxygen? So there's your 2 ions. Those charges come from the periodic table. The next step would be to exercise your crossing down skills. Ta-da! And then what's the last part? Is to turn those charge numbers into opposite subscripts. So here's our final formula. It's going to be Al2O3. And again, just as a reminder, the name of this, we name the metal, and then we name the non-metal, but we change the ending to IDE. So it's aluminum oxide is the name of that. So again, this is the type that we've already covered. Okay, moving on. Type 2 binary ionic, this is kind of the reason why this video is here. Type 2 compounds are a little more complex. Remember in the last unit I said the transition metals, it gets complicated? Well, so here's where we kind of have to start dealing with it. Luckily, there's some easy ways to work on this. Transition metals have more than one charge, and we have to indicate what that charge is. It's not something you have to memorize. It's something you'll either be able to tell from the name, or you'll be able to figure it out from the formula, which is a little bit harder. But there's always information in the formula to help you figure out which it is, because they're different. So here's an example of two different type 2 binary ionic compounds. These are both formed between iron and oxygen, but there's two different forms. This one over here on the left is Fe2O3. This is iron 3 oxide, and you can kind of start to see how we indicate which it is. Iron 3 means it's iron with a 3+ charge. This black stuff that's over here is a different form of iron and oxygen called iron 2 oxide. And again, we've got a little Roman numeral 2 that tells me its charge is a 2+. And they look different. I'll go back to that real quick. They look different in terms of what they are. This is rust, by the way, this red stuff that you're used to seeing. That's that common form. This is just a slightly different version of iron. So again, the names will indicate what's what, and there'll be a Roman numeral that's in there to tell you what the charge is, not the number of atoms. So now I'll go forward to that next one. Here we go. An example for you. Two different type 2 binary ionic compounds. These are both formed between copper and chlorine. So the top one is copper 1 chloride, and that's the kind of greenish colored one. The bottom one is copper 2 chloride, and it's more of the bluish kind of colored one. They're beautiful, both of them. So how would the formulas for these be different? Remember, the Roman numeral tells you the charge. So this tells you copper is a 1+, and this one down here tells you that copper is a 2+. So, if you want to take a second and sketch it out, I'm about to do it on the screen, but you can probably figure out what the formulas are. So the first one, this means copper is a 1+, chlorine or chloride is always a 1-, so the formula for that green stuff is CuCl. There's chlorine with a 1- charge, copper with a 1+, gives you a 1-to-1 ratio. The second one down here, copper 2 chloride, the 2 means that copper is a 2+ charge, and this is what the formula looks like. So here's our copper 2+ right here. Here's our chlorine 1-. We do the crossing down, and that 2 ends up over here, which gets, I know, a little confusing, but it's copper chloride, and this is copper 2 chloride because it's got that 2+ charge. It gets confusing because a lot of students want to say that that 2, the copper 2, is the number of atoms, and it's not. It's the charge of that particular ion. That's what's going to throw you off, so watch out for that. Okay, a couple of examples going the other direction. How can you write names from the formulas? So here I've got two different versions of a compound that contains the element chromium and oxygen or oxide. Again, they're actually slightly different colors. That's why I picked them. So chromium is kind of a greenish black. The other chromium on the bottom is another kind of a bright green. This is a little bit more tricky because you have to kind of go backwards. I think about it as crossing up in terms of figuring out what they are. So I'm going to do this one up here. It's a little bit easier. So with this CRO, I know the charge of oxygen or oxide is a 2-, and my chromium there, for this formula to be correct, my formula there has to be chromium with a 2+ charge. So I would call that chromium 2 oxide. This one down here is a little bit more complex. Again, I think about crossing up. Oxygen is a 2-, and that's where that little 2 down there came from. Cross it up, right? And that makes sense. So what's the charge of chromium here have to be? Well, if I cross up the other one, it must be chromium 3, chromium with a 3+ charge to it. So with these, here's how you would write their formal names. Chromium with a Roman numeral 2 and oxide, because it's chromium 2+. And this one would be chromium 3 oxide, because it's chromium with a 3+ charge. All right, here's your couple of practice screens coming on here. We're almost done. So which of these would need Roman numerals? Can you identify the difference between type 1 compounds, which don't need Roman numerals because they're active metals, and type 2 compounds, which do need Roman numerals because they're transition metals? So take a second, look across the screen. Which of these are going to require Roman numerals? Hit pause, take a look at it, cross them off, whatever you got to do. Ready for me to go? Here we go. All right, so here's the ones that need it and here's the ones that don't. The ones that don't need Roman numerals, type 1s, are in black. So barium is an active metal, it's an alkaline earth metal. Lithium is an alkali metal, and cesium is an alkali metal. So those are active metals, no Roman numerals are required. You say that 5 times fast, don't laugh. The other ones, the red ones, are the ones that are transition elements, and so these would all need Roman numerals. Lead is in the middle somewhere, it's actually a Harry Potter metal. Vanadium, transition metal. Titanium's a transition metal. Iron is one you've heard of before, transition metal as well. So all those would require Roman numerals. I'm not asking you to figure out what the names are just yet, but those are ones that would need to have some sort of Roman numeral in the name. Okay. There's our names of our basic ones. And I'm going to give you a sec, you know what's coming next. There's the names of our basic ones: barium nitride, lithium fluoride, and cesium, or cesium if you're British, sulfide. Those are the pretty straightforward ones, no Roman numerals required. Now's your chance to hit pause and see if you can figure out the names of the other ones, the FeCl2, TiO, VP, and PbS2. So hit pause, try it on a piece of paper, scratch it out, because I'm about to hit go. All right, how'd you do? So here's your Roman numerals. Iron has to be iron 2+ up here because chlorine's a 1-. So for that formula to work, cross it up. Titanium has to be a 2 as well. Oxygen's a 2-. So therefore the titanium has to be a 2+. You wouldn't cross up 1s here because you know what oxygen is. Down here, vanadium. So we know that phosphide is a 3-. Therefore the vanadium has to be a 3+. So it's vanadium 3-phosphide. And then the last one over here, lead. This is the trickiest one of the whole set. Lead here is kind of a lead 4. This is because sulfur's a 2-. I have 2 of them, so that has to be a total of -4 charges for my sulfurs. Has to add up to be a +4 coming from the lead. That's a tough one. We'll work on some more of those in class. Okay, some practice for you. Can you write some formulas as opposed to writing names? Names is oftentimes more difficult, but can you write some formulas for these following compounds? So here's a few. This is where you're going to get a piece of scratch paper. Hit pause, scratch these all out, and I'm going to come back and put the formulas up here in just a second. So hit pause, don't lie, actually do it, and see what you can do. Okay, here we go. Spoilers coming. So nickel 1 sulfide is Ni2S. You need to have 2 of the charge 1 sulfur nickels. God, I can't even speak today. 2 of the 1+ nickels to balance out the 2- from the sulfur. Potassium iodide is Ki. It's just a type 1 compound. Potassium is 1+, iodine's 1-. Titanium, that thing, by the way, if you forgot your Roman numerals, is titanium 4 oxide. So that means oxide's a 2-. I need to have 2 of those to balance out that 4+ of the titanium. Gold 3 bromide has to look like that. Bromine's a 1-. If gold's a 3+, that means I have to cross down that 3 to make it AuBr3. Strontium nitride, this is a type 1 compound. Strontium is an alkali metal, so it's down there, or sorry, alkaline earth metal, so it's got a 2+ charge. Nitride has a 3- charge, so you just cross them down. And then manganese 2 sulfide, make sure you get that one right, it's not magnesium. Manganese is Mn. So if it's a 2+ and sulfide's a 2-, your formula is Mns. There you go. I hope you did pretty well on that. We're going to practice a bunch more of these, the type 1, type 2, writing names, and then the hard part is figuring out those Roman numerals, writing names. But in terms of writing the formulas, either the crossing down usually is pretty straightforward, so just be careful with your subscripts. See you next time.